Okay, sorry about that. My computer just ran out of memory, so I need to clear some place. For this one, the formula I want to use is SR theta, where R is the radius and theta is my degree measured in radians. So it tells me my diameter is 60. Remember, diameter is twice the radius, so I'm going to do 60 divided by 2 to get my radius, which is 30. And then I'm going to multiply 30 by pi over 3, which will turn into just 10 because 30 divided by 3 is 10, and the pi stays where it is. Same thing for number 4. I'm going to start off by taking the diameter, which is 50, and dividing by 2. Gives me 25. I'm multiplying it by pi over 4, but I can't divide 25 by 4, so it stays as it is. Move on. Someone wants me to find the 6 trig functions, and it gives me a point on the graph. Remember, the formulas I wanted for this one were sine is y over my radius, cosine is x over my radius, and tangent is y equals y over x. That's off the screen. Okay, so that gives me a coordinate point. 3 is my x value, 1 is my y value. I want to use the quadratic formula to solve for my radius. So 3 and 1 are going to be my a and b, so I have 3 squared plus 1 squared equals r squared, because radius is my c now. 3 squared is 9. 9 plus 1 equals r squared. 9 plus 1 is 10. And then when I go to take the square root, I cannot take the square root of 10, so it just simply stays square root of 10. And then, so remember, 3 is my x, 1 is my y, square root of 10 is my r. I almost wrote square root. Okay. Then for these, I just plug into the formulas, and then remember, cosecant is the opposite of sine, secant is the opposite of cosine, and cotangent is the opposite of tangent. So for sine, I have y over my radius, so my y is 1 over square root of 10. I cannot leave it like this. I want to simplify it. Remember to simplify it, I multiply by square root of 10 over square root of 10. Gives me square root of 10 on the top and regular 10 on the bottom. Cosecant, I want to flip the sign, so I'm going to flip the blue one I first wrote. So I just have square root of 10 for my cosecant. Cosine is x over r, so 3 over square root of 10. Same thing like sine, I'm going to multiply by square root of 10 on the top and bottom. And it's going to turn into 3 square root of 10 over 10. Secant flips, so this time I have square root of 10 over 3. Tangent is y over x, so 1 over 3. Cotangent flips that, which is just 3, or 3 over 1. On number 16, I'm going to do the same thing. Negative 12 is my x value. Negative 9 is my y value. I'm going to go solve for my r value. So I have negative 9 squared plus negative 12 squared equals r squared. Negative 9 squared is 81. 12 squared is 144. And I don't know r squared. 81 plus 144 is 225. I'm going to take the square root. This one actually works. The square root of 225 is 15. So I'm going to go through and label my things again. Negative 12 is my x, negative 9 is my y, and 15 is my radius. I'm going to go plug into this formula. I have y over r, which is negative 9 over 15. I can simplify this. Both numbers are divisible by 3. So I'm going to get negative 3 over 5. Cosecant, I switch, so negative 5 over 3. I put the negative on top, but it doesn't really matter where it goes. The negative is just part of the equation, so I can pull it and move it around. Cosine is x over r, so I have negative 12 over 15. Both get divided by 3, so it turns into negative 4 over 5. Secant switches it, and it turns into 5 over negative 4. I could switch this fraction, but since I've already simplified it, and I know if I switch it, and then I will have to simplify it again, so I don't want to do that. Okay, tangent is y over x, so negative 9 over negative 12 turns into, it's going to become positive because it's double negatives, it turns into 3 over 4. Then for cotangent, I just flip it and it turns into 4/3. 17 and 18 are working with the unit circle, so this is very similar to the last two, except unit circle will always have a radius of 1 whenever I'm working with the unit circle. So it tells me it's 270 degrees, so I'm going to start by drawing my graph to figure out where 270 is. So I have 0, 90, 180, 270. I found 270, but I'll just complete it to get 360. So my angle is right here, and this is my point. My x value is 0, and my y value is -1, because I didn't move on the x-axis, and I just went down. X is 0, y is negative. So then I'm going to go find my values. Sine is y over r, so I have -1, and my radius is 1. This just simplifies to -1. Cosecant flips it, -1 over -1 is still -1. Cosine is x over r, which is 0 over 1, which is just 0. Secant flips it, so I have 1 over 0. I cannot have 0 on the bottom, so secant is undefined. Okay. Tangent is y over r, so -1 y over x. -1 over 0, also undefined. So when I'm working with the unit circle, I will always have two answers that are undefined. Cotangent flips that, so I have 0 over -1, which is just 0. Okay, same thing for 18. I'm going to start by labeling. I have 0, pi halves, pi, 3 pi halves, 2 pi. This one's going to be 5 pi halves. And this one will be 3 pi. So my point is right here, where my x value is -1 and my y value is 0. Then I plug into those formulas. So sine is y over r. So I have 0 over 1, which is just 0. Cosecant flips it. I have 1 over 0, which is undefined. And I stay on the screen. Yes, just there. Okay. Cosine is x over r, so -1 over 1 simplifies to -1. Secant flips that, which is -1 over 1, still -1. Tangent is y over x, so 0 over 1, just 0. Cotangent flips that, so I have 1 over 0, which is also undefined. Moving on, 19 and 20 give me these graphs and their equations. It wants me to find their period and their amplitude. So I'm going to start off by just highlighting where they're oscillating around, or just bouncing around the middle lines. This one is right there. I cannot draw straight lines. Okay, my period is how long it takes to complete one cycle. So if I start right here, and I end right here, it's going to start up and do the same pattern over again. So if I look down here, it's a little hard to read, but it takes pi times to move around. My amplitude is the distance between that green line I just drew and either the highest point or the lowest point. So the line I drew is at 4 and the high point up here is at 7. That's a distance of 3, so my amplitude is 3. This is a sine graph. Sine graphs normally start at 0. This one starts at 0, so there is no phase shift. Okay. Vertical shift is how much it moves up or down. Typically these graphs will be oscillating around 0. So since this is not at 0, and it actually moved up 4, my phase shift is up 4. Domain for sine and cosine graphs will always be all real numbers. And my range is the 2 points it's bouncing between. So I know 7 is my high point, and if I look over here, 1 is my low point. So it's 1 is less than or equal to y less than or equal to 7. Or another way I can write this is 1 square bracket 1 comma square bracket 7. 7 square bracket. Okay. On number 20, I want to see how long it takes to make a full cycle. This one is cosine, so I'm looking for, just kidding, I'm looking from here to here. So this is -3 pi fourths, and this one is 5 pi fourths. So if I do 5 pi fourths minus 3 pi fourths. It gives me a period of 8 pi fourths, which is just 2 pi. Another way I could tell is if there's no number in front of my x, then it's always 2 pi. Amplitude is the distance between the green line and the high point. It goes up 2, so my amplitude is 2. My phase shift means where how much it's moved over. Typically, the graph will start here. If I look inside parentheses, it's got minus pi fourths. This means it's been shifted right pi fourths. Right pi fourths. Okay. Vertical shift means how much up or down. It's not moving at all, so there is no vertical shift. Domain is all real numbers for cosine and sine. And range is where it's bouncing between. So my high point was at 2, my low point is at negative 2. So my range here is negative 2 is less than or equal to y is less than or equal to 2. Then my range can also be written as negative 2, negative 2, 2. Okay? These ones are wanting me to write the cosine function. It tells me that I put a reflector on the spoke of my bicycle wheel. The highest point is 26 off the ground, so this is 26. The lowest point is 2. And so this is like where the ground is. And it's talking about my revolutions and stuff. So, first I want to figure out my amplitude. To figure out my amplitude, I add the two numbers together. No. Sorry. I'm confusing this one. Amplitude, I subtract the two numbers. So I have 26 minus 2 over 2. 26 minus 2 is 24. Over 2 gives me 12. So that's the number that's going to go up front. It tells me my reflector makes 1 revolution per second. So that's my period. I need to solve for B. I'll do this in red. Remember, the formula to find period is 2 pi over b equals whatever your period is. This one is 1. Then I'm going to solve for b. So 2 pi equals b. And the final thing I need to find is my shift up or down. So it's similar to the amplitude. Ooh, this is why I was getting confused. I add the two numbers together. So I do 26 plus 2 divided by 2, which is 28 divided by 2, which is 14. I give myself no room to write. Okay, then I'm going to go and I get y equals 12. The problem told me it's a cosine function, so I'm going to write cosine. My b value, is going to be 2 pi, and then I still have the x as part of the equation. And then my shift up is 14, so I write plus 14 at the end. Okay. 22 is similar, so I have a circle. The high point is 42, the low point is 6, and then the ground is like way down there. So to find my amplitude, I subtract the 2 and divide by 2. 42 minus 6 over 2. That's not much. So I get 36 over 2, which is 18. Then I'm going to find the period. It tells me it's 1 revolution per second. So I have 1, and then I solve for b. So 2 pi over b equals 1. Cross multiply, I get 2 pi equals b. Shift is similar to the amplitude. So this time I add it, so I have 42 plus 6 divided by 2, which is 48 divided by 2, and that gives me 24. Then I go plug into my cosine function. So I have y equals 18 cosine. Then 2 pi is my b. I don't know why that's so hard for me. X. And then my vertical shift is 24. Let's go back to my view. This one wants me to find the other trigonometric functions given the following. So this one I'm going to draw on an actual coordinate plane. It tells me it's in between pi halves and pi, so I'm going to label in pi's, or radians, as they're typically called. Pi halves and pi is right here, pi halves pi. And then it tells me my sign, so negative 4 over, what? That should have been positive 4, sorry. 4 over 5. Okay. And then I need to solve for my third one. So I have 4 squared plus b squared equals 5 squared. 4 squared is 16 plus b is 25. I subtract 16 on both sides. I get b squared equals 9. B is b. So this is my opposite, hypotenuse, adjacent. Then I'm going to go through and fill in these values. So since I told you I made a typo and didn't mean to make this negative, my cosecant just flips and it's 5 over 4. My cosine is opposite over hypotenuse. Opposite? Adjacent. What am I saying? 3 over 5. Cool. Secant takes that fraction and flips it, so it's 5/3. Tangent is opposite over adjacent, so 4/3. Cotangent flips that, so 3/4. Cosine, same thing. I'm gonna go draw this, and hopefully I got my signs right on this one. 0, pi halves, pi, 3 pi halves, 2 pi. This one's in between 3 pi halves and 2 pi, so right here. And cosine is positive, because this one is adjacent over hypotenuse, so I have 3 and 5. From this triangle, I know the side lengths are from 4 and 5, so I'm just going to fill this one in with 4. This is my adjacent, opposite hypotenuse, and I'm going to go fill in the rest. So secant, I just take the fraction and I flip it. I have 5/3. Sine is opposite over hypotenuse, so 4/5. My bad. This should be a -4 because it's actually going down on the. I messed up over here. This would be a -3 because it's going left on the x-axis. So every time I have a 3, it's negative. Over here, it's a -4 because it's going down on the y-axis. So this is -4/5. And I have 5 over -4. Tangent's opposite over adjacent, so -4/3, and cotangent flips it to -3/4. Okay. Moving on, this one wants me to match my graphs with the functions. All 6 are not on the screen. Okay. They're still not all on the screen. Okay. So a graph that goes like this and a graph that goes like those are the same graphs. Either way, they are sine or cosine. None of these are sine or cosine, so I know B and F are out. If I go and I have to zoom circle, so I'm gonna go find cosecant. Cosecant. I want to make it with pi's. So cosecant looks like this, where it's used, but they're not on the y-axis. So if I go back to my paper, cosecant is the C choice. Okay. Then I'm going to go graph secant. This one is right on there. Why did I pick... Okay, I picked the wrong one. I told you one thing and then put it in a different spot. I meant to pick D for this one. Sorry about that, guys. Okay, then I'm going to go graph tangent. This one is a squiggly line going up. I look on here, squiggly lines going up towards the right are A. And then looks like U. And then cotangent is the inverse of tangent, which would leave me E, but let me show you what it looks like. This is cotangent, so there's going to be lines leading to the left. So I'll put that over here. This would give me choice